All right, so then the last thing that's going to show up on your quiz is perpendicular lines. Perpendicular lines tend to be a little bit easier because there's really only one thing you need to know about them. Perpendicular lines make what type of angles? Right angles, which means they are always worth how many degrees? 90. So how could we find x if I give you this? Equal it to 90, exactly. So in this case, 4x minus 30 equals 90 because it's a right angle. And we know it's a right angle because of what? That little box. That little box tells you it's a right angle. So what would I do to solve this then? And you get 4x equals 120. So then divide by 4, x equals 30. And that's it. I'm not really ever going to ask you to plug it back in. Why not? Because every time you plugged it back in, what would it give you? 90. So you're not telling me any information I didn't already know. I knew it was 90 because it's perpendicular. So typically here, you're just solving for x. Okay? It's not like you couldn't do it. You could absolutely plug it back in. It's just not telling me any information I didn't already know. Okay, so those are always going to make a right angle. All right, what about with something like this? How can we solve for x and y here? Micah?
I was thinking equal since they are each.
Okay, so we know that they're both 90, so I could make them equal to each other. That's true. And if I do that, 10x equals 2x plus 15y. That's absolutely true. Nothing's wrong with that. But can I do it? Why not? It's got an x and a y. Okay, Danny, what do you think?
Like, what if you solve for x for 10x to 90?
Yeah.
Have x, plug it into there, and then solve for y.
That's exactly what I need to do. So I need to start with this one. Why do I have to start with this one? It has one variable. So I have to start with that one because that's going to let me solve for x. So I'm going to say 10x equals 90. So I know that x must be 9. Okay, now that I know that, Danny said I can go in and plug that in. And so I can say this one, my equation would be 2. Instead of x, what am I plugging in? 9 plus 15y equals 90. So it's 2 steps instead of 1 step. Could you have done this step mentally?
Yes.
Probably so. You probably could have looked at this and said, well, if this is 90, then x has to be 9. So you might have been able to do that without writing it out. If you can, more power to you. If not, it doesn't hurt. So what's 2 times 9? 18 plus 15y equals 90. What would I do first then? Minus 18, 15y equals 72. And then y equals 4 point what? 4.8. Thank you. All right, y equals 4.8. Good. So Danny described that perfectly. Can somebody else describe to me again just what did we just do? What did we just do there? Solve for x first. Okay. And how did you know to solve this one first rather than this one? That one is alone. That one has one variable in it, so you can actually solve it. And once you've done that, then what do you do with your answer? Plug it into your other one, so that basically now you've made this, so it also only has one variable. Okay? So we've got to get rid of the variable if we can. All right. Understanding that this is true, that they're equal to each other, is also really important. It just doesn't help us in this particular problem because there's 2 variables. All right. So at your boards, try this one. You'll notice it's very similar to the one that we just did. Okay, so these are, again, guys, whenever I have super word-heavy slides, these are not usually, it's just, you can come back to it later if you want to look at it. These are theorems that we're going to go through quickly. These are pretty self-explanatory, okay? So these are pretty self-explanatory. If 2 intersecting lines form a linear pair of congruent angles, so basically a linear pair is a line split into 2 angles. If they're congruent, they have to be 90 degrees because a line is worth how much?
180.
180. So if it's two congruent angles, then they would have to be 90 because 180 divided by 2 is 90. Good. Okay? The perpendicular transversal theorem says that if these lines are parallel, if this angle is 90 degrees, if that angle is 90 degrees, then what do you know about this angle? That one's also 90, which you know because what angle relationship are those? No. We have 4 angle relationships. Which one is this and this? They're corresponding. So if this is 90, this also has to be 90. And then if these are both 90, all the rest of them are also 90. Basically, if one of them is 90, all of them are 90 as long as the lines are parallel to each other. Okay, so once you see those arrows, because again, these have to be, because these are what type of angles? Nope, these two right here. This one and this one. Vertical angles. All right, those are vertical. And if these are 90, they all have to be. Okay, which is pretty much, you guys all assumed that on the last one. All right, this is just that, but backwards. If these two angles are 90, then these two lines must be parallel, which is like the converse of the corresponding angles theorem that we talked about on Friday. Okay, now the other thing is the shortest distance from a point to a line is perpendicular to that line. So basically what this is saying is if I have this point B, and I'm going, we'll call this line, give me a letter, not Araby. C, okay, line C. To get from B to line C, if I give you these 3 routes, which one has to be the shortest one? The one to A, from BA, right? Why?
Because it's in the middle.
Not because it's in the middle.
Because it's going straight down.
Because it's going straight down, and it makes what kind of angles? Right angles. So AB is perpendicular. So if you are going from B to line C, the most direct route is a line that is perpendicular because it's going to be the shortest one. Okay? So that means that I know that AB has to be shorter than 15, and it also has to be shorter than 10. Okay? So I can write an inequality. AB is less than 10. And I know that because it has to be the shortest line. Why don't I put AB is less than 15? 10 is smaller. So not only is it less than 15, but it has to also be less than 10. So you wouldn't write it's less than 15 and it's less than 10 because there's no number that's less than 10 that isn't less than 15 also. All right, so this is an inequality. What's an inequality, just as a reminder from Algebra 1? What's an inequality? Say that louder. That thing that I taught, just the one thing I taught you last year. What does this mean? Less than. Okay, so less than means AB could be what numbers? Anything as long as it's less than 10. All right, so give me 5 things AB could be. 1, 2, 3, 4, 5. Could it be 9.9? Yes. Could it be 9.9999999? Yes, as long as it's less than 10. So do I know how long AB is? No, but I know a lot of options for what it could be. All right, and I know it has to be the shortest because it's the one that makes what kind of angles? 90, so it's the perpendicular line. All right, so this is just that inequality.
So that's the answer?
Yeah, but if I asked you, like, write an inequality based on this figure, that's what you would write. Okay, so what could we write here then? What could we write here? What inequality could we write here? Which one has to be bigger? X plus 3 has to be bigger. So we would say, in this case, our inequality would be x plus 3 is greater than 12. Where'd the 12 come from?
Going down the middle.
Yeah, that's got to be the shortest line. This one has to be the smallest one, which means this one has to be bigger than that. How do you know which way in an inequality, how do you know if it's greater than or less than? Okay.
Like the smallest.
So the alligator thing means what? Okay, so the open mouth should be facing the biggest one. All right, so that's a greater than symbol. The less than symbol also looks more like the letter L. Okay, so the less than looks more like an L. The greater than is opposite. All right, how could I isolate X? Subtract it from both sides. And I know then that X has to be greater than 9. Good. So what could X be?
8, 7, 6, 5.
Nope. Micah, what?
I said 10.
10 to infinity. Because X is bigger or smaller than 9? Bigger. So X could be 10, 11, 12, all the way up to infinity. And all the decimals in between. All right, so that's it. Time's up. We don't have time for your exit ticket today because we took a little more time on the rewind. Oh, no, that's lunch. That's the lunch bell. I do have time. All right. Okay, so I want you guys to do the practice. This doesn't look quite the same as the other one because it doesn't have the other side of the triangle. But which one has to be shorter, AB or BC? Which one has to be shorter? AB, because that's the one that makes the right angle. Okay, good. So for number 1, I want you to write and solve an inequality. For 2 and 3, you're just answering those questions.